Okay, guys, there are some problems on your quiz that I'm going to go through and do, okay, to next time during class when you guys are reviewing. And you can pay attention to me or not pay attention to me, but there are the problems that are commonly missed, okay? Just so you guys know, I will be doing some of those if you want to pay attention. Okay, so if you look at question 6.8 and kind of scan through this, what do you notice about every single problem on this section, you guys? What do you notice? They're all word problems. Yeah. Okay. So look at this formula right here, guys. A of t equals a sub 0 e to the kt. Okay. What I want you to write down is a equals pe to the rt. So the formula that they gave me and this formula, the PERT formula, it's exactly the same thing. So I think that you understand PERT because of the lesson last time, right? Is there anyone else that's wanting to go to the college thing? Okay, I think everybody left. Okay, so A stands for the new amount. So A of t, see how it says amount? I don't like that. Put new amount. So like you start with 10 grams and it goes to 25 or it reduces down to 3. So it's the changed amount. P, you guys know, stands for principal. That's how much you start with. Well, that's the a sub 0. It's just how much you start with. E, you guys know, excuse me, it's just 2.7. R is the rate at which it's increasing or decreasing. That's the same thing as the K. And then T, you guys know, just stands for time. Okay? So if your K is a positive, if it's greater than 0, then it's growing. And if your K is less than 0, then it's decaying, okay? So it could be increasing or it could be decreasing. Okay, here we go with question 1, nice and slowly. The size of a certain insect population at t days obeys this function. It just means it follows this function, okay? What I really, really want you to do is I want you to write t equals and p of t equals. Because, guys, listen. Everybody just kind of look up and freeze for 2 seconds and listen. I have 2 variables right now. This is big to understand this. I have a P of t and I have a t. So they're going to ask me a question and they're going to give me a number. Well, I have to know what P of t and t stand for because I need to know, do I put my number in for P of t and solve for t, or do I put it in for t and then I solve for P of t? Who says I understand what you're saying? Okay, so you have to know what they are. So P is the population, okay? So right here I'm going to put population at t days. So my T just stands for days, okay? What is the initial number of insects? You guys, this is easy because this is how much you start with. So this is just going to be 300 every single time you have a word problem. I don't care how redundant it seems. Redundant means repetitive. I want you to have a label. I need you to stop and think about what that number means. So 300 what, everybody? Insects is correct. And I would expect you to label that. I want you to stop and think about what that means, okay? What is the population after 20 days? Every person in this room. Does my 20 go in for P of t or does it go in for t? Talk to me. T, and T is the easiest one because you just literally just put this in your calculator. So everybody go P of 20 is equal to 300e to the 0.15 times 20. Okay, grab your calculator. Everybody go 300 second ln 0.15 times 20, close it off, enter. Okay, and we're going to round it to the nearest whole. You never, never, never round anything unless, some of you still don't know this, unless what? Unless they tell you to. So I'm changing the problem so we round it to the nearest whole insect. So the answer is 6,026 insects. That's it. Okay, question C. When will the insect population reach 600? There's a lot of people in this room, okay? Does the 600 go in for P of t or does it go in for t? P of t, the population, right? So everybody go 600 equals 300 e to the 0.15 t. Everybody stop right here. I was just grading 1050 tests. Look, what am I, or quizzes, what am I going to ask you right now? What am I going to ask? Are you stuck? What's the answer? No. No, you know what people are doing? They're converting right now. Can I convert right now? No, because what about the 300, right? It's just like hanging out there. So you got to get rid of it. So now you have e to the 0.15t is 600 divided by 300, which is a 2. Are we stuck now?
Yes.
Yes. When you're stuck, what do, everybody?
Convert.
You convert it. So this is log BC of 2, that's ln 2, is equal to 0.15t. To solve for t, you divide, so you have ln 2 divided by 0.15. Everybody stop for just a second. Some of you are doing things like this. You're just like, well, I don't know what it is, so I'm just going to start sticking values in right here until I get something really close to 100, and I'm going to say that's my answer. So I have like a sample of what the final is going to look like, and there are problems like this, and it says right on the directions you cannot solve this by guess and check and plugging numbers in. So they're not going to give you anything. So please make sure you go through this process, okay? Okay, so everybody go ln 2, close it off, divided by 0.15, hit enter, okay? And we're going to say that they said to round to 2 digits. This is never something that you would decide. It would have to be in the directions, okay? So the answer is 4.62, and we have days. Now everybody freeze. Don't touch your calculator. You can check this in 15 seconds. So fast. So why wouldn't you, right? Everybody hit store, enter. Then put this right-hand side in, and you better get 600. So go 300, second, ln, 0.15, membar, enter, close it, enter, bam. I know I got it right. Because when I plugged it back in, I got 600. Okay, who says I'm with you? Raise your hand. Okay, good. Question D. When will the population triple? Okay, everybody stop for 2 seconds. Sorry, we have a question. Go ahead, honey.
So the only time you use it in years, is that only when you're doing interest?
Yes. Money is always years. And I think you probably heard in the video me saying, because this is an APR, which stands for annual percentage rate. So that's why it's always years. Okay, good. And these ones you have to read. Okay. When will the population triple? Guys, listen. When? Which of these two stands for when? T. So I know that I'm looking for T. So over here, I'm going to go 300 e to the 0.15 t. Now I have to have a number on the other side. What's my number on the other side? 900. Okay. What am I going to ask you?
Are you stuck?
And what's the answer to the question? No. We're not. Divide by 300. So e to the 0.15 t is 900 divided by 300, which is 3. Are we stuck now? Yes. Do me a favor, everybody freeze right here for 2 seconds. This is something I haven't said that I think is pretty important. Look at that equation. What I'm solving for is stuck in the exponent. If what I'm solving for is stuck there, the only way I'm ever going to solve it is to convert it. So I knew right there that I would have to convert it. It's the only way to get the t out of the exponent. Who says I understand? Let me see. Great. Okay, so let's convert it. Log base e of 2, that's ln 2, is 0.15 t to solve your divide. So it's ln 3 divided by 0.15. That is my exact answer. And this is days. So if they ask you to write it in exact form, that's your exact form. If they tell you to round it to 2 digits, then let's do that, okay? Grab your calculator. Don't clear it once you do this. ln 3, close it off, divided by 0.15, hit enter. So it would be 7.32 days. Let's check it. Okay, everybody hit store, enter. 300, second, ln, 0.15, membar, enter, close it, enter, bam, I got 900. There's no way I'm wrong. Okay, who says this is easy? Let me see, raise your hand. Yay. Okay, question 2. Let Y represent a mass of radioactive strontium in grams. The quantity of strontium present after T years is given by this equation. Everybody stop. I want you to write T equals, and I want you to write Y equals. Would I ever take points off if you did not do that? No, but it'd be crazy because you're going to get all mixed up in your head if you don't know what stands for what. So T stands for years, and Y stands for grams of strontium. How much you have, okay? What is the initial mass? That's easy, guys. It's right there. It's 10. So your answer is just 10, and this is grams. If you don't have a label, you're going to lose a point. Point for the answer, point for the label, okay? How much is present after 80 years? Everybody in the room, is that a Y or is that a T?
Y.
That's a year. So which of these is years? That's your T, right? So everybody go Y equals 10e to the negative 0.025 times 80. Everybody stop right here for a second. Do you think it's going to be more than 80 or do you think it's going to be less than 80? Talk to me about that. It's going to be less. How do you know it's less? You've got a negative in your exponent, so it's going down. Yes, good. Okay, everybody go 10 second ln negative 0.025 times 80, close it, enter, and let's say they said 3 digits. That would have to be them saying that. So it's 1.353 grams. Okay? When will half remain? Okay? So I know when is time. So I'm going to leave my time at time. Everybody in the room, tell me what I put on the left-hand side. Yeah, you know what some people do? They put a half. That's not true. That's not correct. Because if I start with 10, then half of 10 is 5. What do I do right here? Do you know? Divide by 10, right? You have to get rid of the 10. Yes, honey? Some people like to go right to the next step. I think I would rather you not go to the next step because it takes you like 2 seconds. Probably not, but I'm afraid you're going to miss it. Yeah. Okay, so divide by 10. So e to the negative 0.025t is equal to 0.5. Now I convert ln 0.5 is equal to negative 0.025t. And now I divide. So I have ln 0.5 divided by negative 0.025. So everybody go ln 0.5, close it off, divided by negative 0.025, hit enter. There's my answer. Let's say they told us to go 3 digits. They would say that in the directions, and it's 27.726. They want to know when, and this would be, is it days? Years. Okay, so that would be years. Store it in, plug it here, make sure you get a 5. You can check it. I think one time I figured this, actually I think last year, and I think that about 70% of test 3 is checkable. Get your answer, plug it back in. Okay, pretty sure. All right, question 3. Now we're going to slow down a little bit. Okay, the number of bacteria in a culture is given by this equation, where T is time in hours and N is 280 when T is a 2. Everybody stop right here for a second. Everybody freeze. Don't go ahead of me, okay? Please, this is not going to be easy beyond this point, and I don't want you to get confused. It looks like they gave us an equation. But did they really give us an equation? Is there really an equation right there? I mean, clearly there's an equation, but do we have all the necessary details of the equation that we need? We don't. Compare this to the last equation we were given, okay? Look at what you're given and look at what you're not given. So what do I not know in this equation that I did know in all the other equations? The value of K is exactly right, okay? So step number 1 is to find your K. Step number 2 is to find the model being the full equation, okay? Step number 3 is to answer your question. These are the 3 steps that we're going to follow for the rest of this lesson. Because guess what, you guys? They're not going to give us an equation anymore. So it's easy when they give it to us. You just pop it in and go, right? Now we have to come up with the equation. Okay, here we go. What is the initial amount? It's right there. Okay, so it's going to be 250 and okay, let's figure out what things stand for. So we've got an N and we've got a T. So N is the number of bacteria and T is time in hours. So the initial amount is 250. Is it bacterium or does anybody know? It is IUM if there's more than one. Okay, see how smart you are. Okay, so 250. Okay, find the growth rate. Here's what you do to find the growth rate. Everybody look right here. Okay, listen, look right here for 2 seconds. I'm a scientist, and I've got a petri dish, and I've got bacteria, and I'm trying to see how quickly these bacteria spread in different conditions. So I start my experiment. When I begin, I have 250 bacteria. Then my experiment's going on, I'm going on. I have to get my data. So at some point in my experiment, I'm going to grab my petri dish, I'm going to hold it, I'm going to count it, and then I'm going to use that data to make some conclusions of my experiment. Who says I understand what you're saying? Okay, so in order to see how quickly the bacteria is growing or decaying, I have to have that random data in the center, right? Here's the data right there. So they're going to say, after this long, I've got this many bacteria, okay? So what we're going to do is we're going to put 280 in for N, we're going to put 2 in for T, and we're going to do step 1, which is to find my K. So everybody go 280 equals 250 E to the K, which I don't know, times 2. So that would be 2K. I'm not stuck, so I divide. So I have E to the 2K equals, if you go 280 divided by 250, you get a nice number, 1.12. What's the definition of nice right now? Tell me. It ends. It's not like this crazy, horrible thing, right? So we're stuck, so we convert it. Log base E of 1.12 is ln 1.12 is equal to 2K, and then I divide, and I get ln 1.12 divided by 2. Okay, now you have to listen carefully. Everybody go ln 1.12, close it off, divided by 2, and then I want you to hit enter. Okay, and you get K is, let's say the direction said to go 4 digits, and you get K is approximately 0.0567. Okay, now I want to have a conversation with you. That's the end of that part A or whatever, part B. If I use that number, 0.0567, I put it into my equation, and I use that number to answer the next thing. Am I right or am I wrong? I'm wrong, because tell me why. This is an approximation. You guys are going to grow up and do wonderful things. Some of you are going to be engineers. If you start calculating things on a rounded number, your bridge is going to fall. It's not going to work because that little error gets bigger and bigger and bigger. So to prevent that, what do I have to do right now? What do I have to do? Store it in. Everybody hit store, enter. Okay. Step 2 is to find the model. Okay, look, you guys, this is my model right here. Actually, you know what I want you to do? Right there on step 2, write this down. I want you to write A equals PE to the RT. Or it could be CE to the KT. It all means the same thing. I want you to highlight the P, and I want you to highlight, no, I don't want to do that formula. Sorry, erase it. Everybody write C equals, no, sorry. CE to the KT. Everybody write CE to the KT, and it's A equals. Okay, it doesn't matter. We could have written PE to the RT. I just wanted my case to match up. Okay, so here's what I'm trying to tell you. See this C right here? Highlight it. See the K right there? Highlight it. Then off to the side, tell yourself if something's highlighted, you stick a number in. So you're not going to stick a number in for A, you're not going to stick a number in for T. You're just going to do the initial amount and the rate. Look right here for 2 seconds so I can make a connection. Look back here. In this problem where they gave you the formula, they gave you the initial and they gave you the rate. They didn't put anything for A or T. Okay, so over here where I'm doing it, I'm not going to put a number in for A or T. Those have to stay open. Okay, who says I'm with you? Raise your hand. Okay, good. Now let's make our model. So everybody put down n equals, we'll just go with how they have it, n equals 250 e to the 0.0567 times t. That's my model. Now I'm back to the original problem. Now it's easy, okay? If you didn't store that value of k in, please do that right now, okay? Now I'm back to the original problem. 5 hours, okay? Well, what does n stand for? What does t stand for? We wrote that down. N stands for bacteria, t stands for hours. So my n is going to go in for my 5 is going to go in for my t. So everybody write n equals 250 e to the 0.0567 times 5. Who says I'm with you? Let me see how we're doing. Okay, great. Grab your calculator and go 250 second ln. What am I going to put in right now? Can anybody tell me? It's going to be membar enter, and then what am I going to do with that? Times it by 5. So I'm going to go 5 membar enter, close it, enter. Okay, and let's round this to the nearest whole. Okay, so the answer is 332 bacterium. I think bacterium might be 1. I don't know. We can Google it later. We'll just say bacterium, okay? Okay, find the time for the population to double. Guys, just keep using that model. Find the time. So everybody put equals 250 e to the 0.0567 t for the population to double. Tell me what I put on the other side. I started with 250, so now I'm 500, right? What do? You don't convert. Please don't convert. What do? Get rid of that 250. So you have e to the 0.0567 t is 500 divided by 250, which is 2. Tell me what to do now. Now you convert, right? So it's log base e of 2, ln 2 is 0.0567 t, divide ln 2 divided by 0.0567, okay? If they asked you to write that in exact form, that would be your answer, and this is hours, that's exact. If they asked you to round, let's say, to 2 digits, then you'd go ln 2, close it off, divided by 0.0567, hit enter. Oh, yeah. I didn't do that on purpose. I did not do that on purpose. And my answer would have been wrong because I used a rounded version. Good. I just love being your guys' teacher. You don't let me get away with anything. I love it. ln 2, close it off, divided by member, enter, enter, and 2 digits would be 12.23, and that would be hours. Everybody in the room tell me, is this checkable?
Yeah.
Okay, don't touch your calculator. I got to teach you something, okay? We got that, right? Everybody hit store. This is big. I don't want to put enter because A is my what? A is my rate. So I got to go to the right and hit enter. So now I've got this guy stored in as B, and I've got this guy stored in as A. So to check it, I'm going to do this. 250, second ln, membar enter, membar right enter, close it, enter, 500. So easy to check these. Okay, who says I'm good? Let's see. Okay, yay. Okay, question C. The maximum capacity of bacteria is 2,000. Is this a good model for this situation? If so, when will the bacteria count reach 2,000? Okay, well, let's see. Let's just put it in and see what happens, and then we'll kind of analyze the information, okay? So 2,000 is what I'm going to put there. And then I have 250 e to the 0.0567 t. Divide. So e to the 0.0567 t is equal to 250 divided by, or 2,000 divided by 250, which is 8. Now I convert it. ln 8 is equal to 0.0567 t. Divide. T equals ln 8 divided by 0.0567. Okay. Now let's put it in and see what we get. So everybody go ln 8, close it off, divided by membar, enter, enter, and I get 36 point, if they told me to go like maybe 4 digits, let's go 3 digits, then it would be 36.698, and this is in hours. Is it reasonable to conduct this experiment for 36.6 hours? What do you think? I think it is. I'm sure people do it way more than that. If they did 36.698 million years or something like that, would you do that? No, you wouldn't do that. So is this reasonable? Yes, it's fine. Okay. Okay, here we go with question 4. Okay, how much time do I have and how much more do I have to do? So a page, page and a half, couple pages really, right? Yeah, about 2 pages left. And we get out at when? 27? Okay, we're good. We're good. We'll be fine. We'll finish for sure. Okay, question 4. No equation. None. In a research experiment, a population of 100 fruit flies is increasing according to the law of exponential growth. After 2 days, there are 300 flies. How many flies will there be after 5 days? Okay, stick with me. Please, please, please. Okay, step number 1, find your K. Step number 2, find your model. Step number 3, answer the question. Okay, everybody write A equals C e to the KT. C is the initial, K is the rate, T is time, A is the new amount. Okay, so it says you start with 100. That's my C. So I'm going to put 100. I know that my K is going to stay a K. That's what I have to find, right? So I have to put a number in for T and a number in for A. Remember, that's like a random data point in my experiment. So there's my data point right there. After 2 days, there are 300 flies. The only reason you know that is so you can see how quickly the flies are increasing, okay? So after 2 days, I'm going to put a 2 right there. There are 300 flies, okay? Who is absolutely with me? Like no question in your mind. Okay, wonderful. What do? Divide, right? So you have e to the 2k is 300 divided by 100, which is 3. One word that tells me what to do next. Convert. So it's log base e of 3, that's ln 3, is equal to 2k, divide ln 3 divided by 2, right? Grab your calculator. Everybody go ln 3, close it off, divided by 2. Tell me what to hit right now. Store, enter, right? Then I'm going to say k is approximately. It's pretty typical to take k out 4 digits, so I'm going to say 0.5493. They're not even going to tell you to find your K, find your model, answer the question. They're just going to say what's the answer. So carry it out as long as you want. I would go at least 4, but store it. Okay. The next step is to find the model. Guys, look. Here is what it's got to look like. All I'm going to do is put a number in for C and a number in for K. So I have my new amount is 100 e to the 0.5493 t. Now I'm back to when we started this lesson. So T stands for days, and A stands for the number of flies. This is disgusting. How many flies will there be after 5 days? Where do I put my 5? In for A or in for T? In for T, right? T is days. So everybody say A equals 100e to the 0.5493 times 5. Everybody stop for 2 seconds. Listen right here. What if I put this in my calculator and I got 0.946? You know immediately you're wrong. Immediately. How do you know without even knowing anything further it's wrong? Yes. Yeah, I started with 100. The number I get has got to be bigger than 100. Right? So when you're done, like take a second and analyze, like does that even make sense, right? Okay, so grab your calculator. Everybody go 100, second ln, 5, membar, enter, close it, enter, and I get 1,000. We're going to round this to the nearest whole, 1,559 flies. Disgusting. Yeah. We'll talk about it, but we just don't want to see them or anything like that. That's it. Who says I understood that? I feel good. See, you guys have always been afraid of word problems. Who says, yeah, that's me. I've always been afraid of those. Yeah, it's not scary, right? You guys are smart. Okay, 5 is a little tough, I think. When we start talking about half-life, I feel like people start getting a little confused. Okay, the half-life of carbon-14 is 5,715 years. Find an exponential function modeling carbon-14 decay. Okay, step number 1, find your K. Step number 2, find your model. Step number 3, answer the question. They want the model. Okay, so we have to do K and then the model. So, everybody write A equals CE to the KT. Okay, so I know I have to find my K, so my K is going to be a K. So now I have 3 numbers that I have to fill in. I have to fill in an A, I have to fill in a C, and I have to fill in a T. Carbon-14, I mean, you guys would never do this. You don't use the number 14, obviously. That's part of the name, right? So you would never use the 14. They do give me 5,715 years, so I'm going to put that in for time. That's the half-life. So you guys know this from science. Everybody listen. You have 100 grams of a substance, and its half-life is 1,500 years. So after 1,500 years, my 1,000 grams have gone down to, tell me, 500. And then after another 1,500 years, my 500 goes down to 250, and then 125, and then, you know, whatever the next one is. Okay, but I don't have any more information. So they tell me that that's the half-life, but they don't tell me how much I started with. So what do? You make it up. Isn't that weird? You just make it up. And I always, always, always choose 100. Why do I choose 100? Because it's easy, right? So if I'm going to start with 100 and one half-life cycle has passed, how much do I have left? 50. Not 1/2. It's 50. What do I do now? Everybody in this room, tell me. Divide by 50. Or by 100, sorry. So you have e to the 5,715k is equal to 50 divided by 100, which is 0.5. Tell me what to do now. Convert it. So it's ln 0.5 is equal to 5,715k. So now I have k equals ln 0.5 divided by 5,715. Okay, grab your calculator. ln 0.5, close it off, divided by 5,715. Then I'm going to hit store, enter, and I'm going to say k is approximately negative 0.00012. I went out 5 digits. Okay. Am I surprised that my k is negative? Is that surprising? Why not? It's a half-life. It's going smaller, smaller, smaller. Okay. They want the model. Guys, look. Here's my model. Put in whatever the C is and put in whatever the K is. The problem is, I don't know what C is. When you write down the model, you can't make it up. The model has to work all the time. So if you don't know it, leave it as C. So I'm going to say A equals CE to the negative 0.0012 T. There's my model. Okay. Now I know I have an extra variable. That's okay. Let's do part B. In 1947, jars containing the Dead Sea Scrolls were found by an Arab herdsman. Analysis indicated that the scroll wrappings contained 76% of the original carbon-14. Estimate the age. Okay, what are they asking me for? They're asking me for T, right? So I'm going to go E to the negative 0.00012 T. Now I have to have a starting point and I have to have a new amount. Somebody talk to me. What do they tell me? They still don't tell me. What's the easiest number to choose? 100. If I put 100 right here, somebody tell me what I'm going to put on the other side. 76. Yeah, 76% of 100 is 76. That's why we choose 100, because it's so easy. What do? Everybody talk to me. Divide, right? So you have E to the negative 0.00012 T is equal to 0.76. One word that tells me what to do next. convert. So it's log base E, which is ln, of 0.76 is negative 0.00012 t. To solve for t, ln 0.76 divided by negative 0.00012. Okay, grab your calculator. ln 0.76, close it off, divided by memvar, enter, enter, and we're going to say to the nearest whole. Okay, so we're going to say 2,263 years old. Can I check it? Yes. Let's practice checking this one more time. Okay, the whole AB thing. Okay, everybody hit store. I don't want to hit enter right now because then I'm going to override my K. So you have to go to the right and hit enter. So to check it, guys, I'm going to put this in. The two things up in my exponent would then be A and B. So I'm going to go 100 second ln, memvar, enter, memvar, right, enter, close it, enter, bam. It's right? Yes, sir.
Why do you want it as a
I just made it up. I just made it up. I've thought about going through my notes and all these rounding things, adding word around it. It doesn't matter. It's just very, kind of random. But I think if it wasn't there, then maybe we wouldn't have the conversation about rounding. So I always just say, let's go whole on this one. Okay? Okay, estimate the age of a fossil that has 40% of its carbon-14. So look what you do. Here's this model. Okay? Here's my model that I'm going to use for every question that I now get about this. Estimate the age. So I know my T is going to stay a T. I need an initial amount and I need a new amount. Somebody tell me what to put initially. 100. And what do I put for my new amount? 40. This is easy, right? Divide by 100. E to the negative 0.00012 t is equal to 0.4. 40 divided by 100. Now I convert it. ln 0.4 is negative 0.00012 t. Then you divide, so it's ln 0.4 divided by negative 0.00012. Everybody go ln 0.4, close it off, divided by memvar, enter, enter, and we'll go, just so you feel good back there, we're going to go 3 digits, okay? Okay, so it's going to be 7,554.82, and that would be years. Okay? Oh, did I say 3? I was too busy being smart aleck. 19. Right? That's funny that I did it wrong. Okay. Okay, here goes question 6. The half-life of a substance is 2,300 years. If 20 grams are present now, how much will be present in 5,000 years? Everybody write this down. Okay. Model. Question. When you do your homework and you start feeling overwhelmed, just remember those steps. Okay. So everybody write A equals CE to the KT. I know my first step is to find a K. So see how I put that K there? Now I have to put a number in for T and C and A. I can't solve an equation for K if I have another variable in there. Everything has to be numbers, okay? So, 20 grams are present now, so I'm going to put in a 20. I know the half-life is 2,300 years, and after 2,300 years, my 10 is going to, or my 20 is going to go to, I hate it when I do that, 10. Yes. Divide by 20. So you have E to the 2,300K is 10 divided by 20, which is 0.5. Convert it. ln 0.5 equals 2,300K. Divide. ln 0.5 divided by 2,300. Grab your calculator. ln 0.5, close it off, divided by 2,300, hit enter. Okay, and we're going to say K is approximately negative 0.0003. They didn't tell me where to round. It doesn't matter where I round because I'm going to store it and I won't round until the very end. So everybody hit store, enter. Now I'm going to write down my model. So everybody go A equals. You start with 20. E to the negative 0.0003 t. Now I'm going to answer my question. How much is present after 5,000 years? You guys, if they give you the years, that's the easiest scenario because it's a calculator problem. Now, make sure you write it down. So it's 20e to the negative 0.0003 times 5,000. So everybody hit 20 second ln 5,000 membar, enter, close it, enter, and we're going to go 3 digits, and it's going to be 4.43, and this label is in grams, and I'm done. Okay? Yes, sir. Yes. Thank you. All right. This right here is a logistics model, okay? You don't even really have to know that. Let's just do it, okay? This equation describes the number of people that are sick with the flu after the initial outbreak in a town of 30,000 people. Okay, so let's take 2 seconds and let's say t equals and f of t equals, okay? So f of t is the number of people that are sick, and t stands for the number of weeks that have passed. So you guys are all college students, you're all away at college, you go home for Thanksgiving, you go back home, somebody has the flu and starts spreading it to all the kids on the campus. That's the scenario, okay? And there's 30,000 people that go to school at the U, for example. I think that's pretty close. How many people become sick with the flu when the epidemic begins? Now, this one's not as straightforward on this question. You can't just look at it and know, okay? When the epidemic begins, the value of t is what? Can anybody tell me? It is 0. No time has passed. So I want everybody to go f of 0 is equal to 30,000 over 1 plus 20 e to the negative 0.15 times 0. Okay? Now I want everybody to stop right there for just a second. This is super important. Look at your equation. On the bottom, it's complicated. I've got 2 separate terms. So whenever I put the bottom of that problem in my calculator, what do I have to do? Parentheses. So right now, I want everybody to put parentheses right there. Okay? And on part A, I want you to put parentheses right there. If you forget those parentheses, you're going to get it wrong. Okay? Everybody go 30,000 divided by parenthesis 1 plus 20 second ln negative 1.5 times 0, close it, enter, and you get, we're going to round to the nearest whole, so it would be 1,429. You guys, if you don't have a label, you're going to miss it, because I don't know that you know what that stands for. What does it stand for? People. Yes. Question B. How many people were sick by the end of the 4th week? Everybody tell me where I put my 4. T or F of T? T. So this is an easy one. This is a calculator problem. So everybody go F of 4 is equal to 30,000 times 1 plus 20 e to the negative 0.15 times 4. Okay. Now you can do this. Hit your up arrow for me. Actually, yeah, I think you have to hit it once. Then go over to the right until you're on top of that 0, and then just push in a 4 on top of that, hit enter, and there's your answer. So you don't have to stick the whole thing in, okay? So we're going to round this also to the nearest whole, and the answer is 28,583 people. Almost everyone is sick, because we have 30,000 that go to school and 28,000 people are sick. Find the time when half the population is sick. You guys, I know my time is going to stay a t. My t is going to be a t. This is a little bit tough, so I want you to watch closely to this, okay? Somebody tell me what to put on my left-hand side. 15,000, half, right? Now I'm going to show you a trick. I really want you to use the trick because it's going to save you some heartache, okay? Look at the problem and tell me what we have to do to solve this. Cross multiply, right? So everybody put a 1 right there. Now everybody freeze. Do you see this 15,000? How it goes perfectly into 30,000, right? I'm not going to distribute it. I'm going to cross multiply, but I'm not going to distribute because I can make the problem look so much easier in just like 2 steps. Okay, so look, cross multiply. So you have 15,000, parenthesis, 1 plus 20e to the negative 1.5t, okay, equals 1 times 30,000 is 30,000. Okay. Does anybody see what I can do to make the numbers way better right now? Yeah, it goes perfectly. So divide by 15,000. So you have 1 plus 20 e to the negative 1.5t is 30,000 divided by 15,000, which is 2. Okay, this is a good review from the quiz. Are we stuck?
No.
What do? Move your 1, right? So you have 20e to the negative 0.15t is 2 minus 1, which is 1. Do I convert right now? No, you have to see it right, guys. You see 20y equals 1. So what do? Divide. So I have e to the negative 1.5t is equal to, everybody go 1 divided by 20, and it's nice. If it wasn't nice, stop for a second. If it wasn't nice, what would I do? You could store it. You know what I would do? I would just keep it as 1/20th. Okay? Because I also want my work to look pretty accurate and not have a ton of rounded numbers. Okay? But that's not the situation here. This is 0.05. Now I'm stuck, so I convert it. So it's log base e of 0.05, ln 0.05 is negative 1.5t. To solve, you get ln 0.05 divided by negative 1.5. Okay, grab your calculator, ln 0.05, close it off, divided by negative 1.5, hit enter, and we're going to go, let's say we're going to go 3 digits. Okay, so it's going to be 1.997, and this is weeks, is that right? Yeah, weeks. Can I check it? Is it checkable? Yes. What do? Put it here. Make sure you put parentheses, and what should I get? 15,000. Okay? So it's absolutely checkable. Okay? All right. Who says I understand that lesson? Raise your hand. Okay, yay. We did it in 47